What if I told you that Norway has carved over 1,000 kilometers of tunnels through some of the hardest rock on Earth, creating an underground highway network that connects remote Arctic communities and has transformed life for 5 million Norwegians who can now travel anywhere in their country regardless of weather or season? It sounds like science fiction, right? Well, Norway has been quietly building this subterranean transportation empire for over 30 years, and the result has created the world's most advanced underground infrastructure system. This is that incredible story of conquering mountains from within. But to understand why Norway would attempt to drill thousands of kilometers of tunnels through solid granite and gneiss rock, we need to go back to the early 1990s. That decade, Norway faced a geographic challenge that threatened to keep its communities permanently isolated and limit the country's economic development for generations to come. Picture this. Norway's dramatic landscape of fjords, mountains, and islands created one of the most beautiful but practically challenging geographies on Earth. The country stretches 1,150 kilometers from south to north, but mountainous terrain and deep fjords made surface transportation extremely difficult. Many communities could only be reached by ferry, aircraft, or treacherous mountain roads that were impassable for months during Arctic winters. The numbers surrounding Norway's transportation challenges were staggering. Over 40% of the country's population lived in communities that were effectively isolated for 3 to 4 months each year due to weather conditions. Ferry crossings were required for 150 different routes, with some journeys taking over 6 hours to travel just 50 kilometers. Economic development was severely limited because businesses couldn't rely on year-round transportation connections. But Norway possessed something that made underground transportation feasible: some of the most stable geological conditions on Earth. The Norwegian mountains consisted primarily of Precambrian bedrock that was over 1 billion years old. Incredibly hard, but also extremely stable for tunnel construction. More importantly, Norway's oil wealth provided the financial resources needed for massive infrastructure investments. The challenge seemed insurmountable. How do you drill tunnels through mountains that rise over 2,000 meters above sea level? How do you maintain safe working conditions when boring through rock that can crush conventional equipment? Most critically, how do you make tunnel construction economically viable when the costs and engineering challenges are unprecedented? The Norwegian government recognized that conventional surface transportation would never solve the country's connectivity problems. Mountain roads required expensive maintenance, were dangerous in winter conditions, and couldn't provide reliable year-round access. Ferry systems were limited by weather and couldn't handle the traffic volumes needed for economic growth. The solution that emerged was revolutionary. Norway would build the world's most extensive network of underground highways, drilling directly through mountains and under fjords to create climate-proof transportation connections. These wouldn't be simple utility tunnels. They would be full-scale highway tunnels capable of handling trucks, buses, and emergency vehicles in all weather conditions. Critics thought the plan was geological madness. Dr. Erik Haugen from the Norwegian University of Science and Technology argued that drilling thousands of kilometers of tunnels through Norwegian bedrock is engineering suicide. The rock formations are too complex, the water infiltration too severe, and the costs too enormous for such massive construction to succeed. International tunnel engineering experts were equally skeptical. The scale of rock drilling proposed for Norway was unprecedented in civil engineering. Environmental groups raised concerns about the ecological impacts of massive underground construction. Drilling through mountains could disrupt groundwater systems, affect surface vegetation, and create permanent scars in pristine wilderness areas. There were also worries about the disposal of millions of tons of rock waste generated by tunnel construction. Local communities were divided on tunnel projects. Some enthusiastically supported underground connections that would provide year-round access to services and economic opportunities. Others worried about construction disruption, property damage from blasting, and changes to traditional ways of life that had adapted to seasonal isolation. But Norway had several advantages that made large-scale tunnel construction feasible. The country's advanced engineering capabilities, developed through offshore oil drilling, provided expertise in working in challenging conditions. Norway's stable democracy allowed for long-term planning and consistent investment over multiple decades. Most importantly, The economic benefits of improved connectivity would far exceed the construction costs. The tunnel construction program officially launched in 1994 with the beginning of work on the Lærdal Tunnel, designed to connect eastern and western Norway through a direct underground route beneath the mountains. The project required developing new tunnel boring technologies specifically adapted to Norwegian rock conditions and safety requirements. But building the world's longest road tunnel required solving engineering problems that had never been confronted before. How do you provide ventilation for a 24-kilometer underground highway? How do you ensure safe evacuation routes if vehicles break down or accidents occur deep underground? Most critically, how do you prevent dangerous vehicle emissions from accumulating in enclosed spaces? The solutions required innovations in every aspect of tunnel design and construction. Advanced ventilation systems with emergency air supplies were installed throughout the tunnel length. Emergency evacuation chambers were built every 500 meters to provide safe refuge areas. State-of-the-art monitoring systems tracked air quality, traffic flow, and emergency conditions continuously. The rock drilling process itself was a technological marvel. Tunnel boring machines weighing over 2,000 tons were specially designed for Norwegian granite conditions. Controlled blasting techniques minimize vibration and environmental impact while maximizing excavation efficiency. Advanced geological survey methods identified potential problems before drilling encountered them. The completion of the Lærdal Tunnel in 2000 exceeded every expectation and proved that underground highway construction could succeed in the most challenging geological conditions on Earth. But the Lærdal Tunnel was just the beginning of Norway's underground highway revolution. The success encouraged massive expansion of tunnel construction throughout the country. By 2005, Norway had over 900 active tunnel projects in various stages of planning, construction, or completion. The country was literally redesigning its geography through underground engineering. The most ambitious project was the Rogfast Tunnel, designed to connect the Stavanger region through an underwater tunnel beneath the Boknafjord. This tunnel would be 27 kilometers long and reach depths of 392 meters below sea level, the deepest underwater road tunnel ever constructed. The engineering challenges exceeded anything attempted in the Lærdal project. Building underwater tunnels through fjord geology required completely new approaches to tunnel construction. The tunnels had to withstand enormous water pressure while maintaining structural integrity in unstable seafloor sediments. Waterproofing systems had to prevent catastrophic flooding while allowing for emergency evacuation. Advanced geology prediction was essential to avoid drilling into underground water sources. The construction techniques developed for Norwegian tunnels revolutionized underground engineering worldwide. Tunnel boring machines designed for Norwegian conditions were exported to major infrastructure projects in Switzerland, Italy, and China. Norwegian tunnel engineering companies became global leaders in underground construction technology and expertise. International recognition of Norway's tunnel achievements led to consulting contracts for major projects worldwide. Norwegian engineers designed tunnel systems for the Gotthard Base Tunnel in Switzerland, the Channel Tunnel expansion, and underground highway projects in South Korea. Norway had become the global capital of tunnel engineering expertise. The economic transformation was dramatic. Communities that had been isolated for centuries suddenly had year-round access to major cities and economic centers. Tourism increased dramatically as visitors could reach previously inaccessible areas regardless of weather conditions. Property values in remote areas increased significantly as transportation improved connectivity. Rural depopulation, which had plagued remote Norwegian communities for decades, began to reverse as tunnels made it feasible to live in isolated areas while working in larger cities. Young people who had left for urban areas began returning to rural communities that now offered both traditional lifestyles and modern economic opportunities. The environmental impacts were generally positive, despite initial concerns. Tunnels eliminated the need for mountain roads that required extensive environmental disruption. Wildlife migration patterns were less affected by underground infrastructure than surface transportation. Most surprisingly, tunnel construction often improved local hydrology by providing controlled drainage for mountain watersheds. By 2010, Norway had completed over 500 kilometers of highway tunnels, making it the country with the highest tunnel density in the world. Average tunnel length exceeded 1.5 kilometers, with many tunnels stretching over 10 kilometers through solid rock. The tunnel network was handling over 100 million vehicle trips annually, demonstrating the demand for climate-independent transportation. Technology continued to evolve with each new project. Smart tunnel systems incorporated traffic management, environmental monitoring, and emergency response capabilities. LED lighting systems provided energy-efficient illumination while reducing maintenance requirements. Advanced ventilation systems maintained air quality while minimizing energy consumption. The success attracted massive international investment in Norwegian tunnel technology and expertise. Construction companies, engineering firms, and equipment manufacturers established operations in Norway to participate in the growing tunnel economy. Norway had created an entire industry based on underground infrastructure development. Climate change adaptation became an important benefit of tunnel infrastructure. As extreme weather events became more frequent and severe, underground transportation provided reliable connectivity regardless of surface conditions. Tunnels were unaffected by storms, flooding, or temperature extremes that could make surface roads impassable. By 2015, Norway's tunnel network exceeded 800 kilometers and was approaching the government's goal of 1,000 kilometers of underground highways. The system was handling over 150 million vehicle trips annually and had become essential infrastructure for the Norwegian economy. Tourism, commerce, and daily life had been transformed by underground transportation. Emergency response capabilities were dramatically improved by tunnel infrastructure. Ambulances, fire trucks, and police vehicles could reach remote communities year-round instead of being blocked by weather conditions. Medical evacuations that previously required helicopter transport could be handled by ground vehicles through tunnel networks. The cultural transformation was equally significant. Norwegian identity had historically been shaped by geographic isolation and seasonal rhythms. Tunnel infrastructure allowed for new forms of community and economic activity that weren't dependent on traditional geographic constraints. Rural areas could maintain cultural distinctiveness while participating in national economic life. Educational opportunities expanded dramatically as students in remote areas could access schools and universities that had previously been unreachable. University campuses established satellite facilities in previously isolated communities. Distance learning was supplemented by physical access that tunnels made possible. What happened from 2015 to 2024 completed Norway's transformation into the world's most connected underground transportation system while establishing new global standards for tunnel engineering and infrastructure development. By 2024, Norway had achieved its goal of over 1,000 kilometers of highway tunnels, creating the most extensive underground road network on Earth relative to population and area. The most remarkable achievement was the completion of the underwater tunnel network that connected Norway's most isolated island communities to the mainland highway system. The Rogfast Tunnel, opened in 2022, created a 27-kilometer underwater connection that eliminated ferry dependencies for over 150,000 residents. The tunnel reached 392 meters below sea level, making it the deepest underwater road tunnel ever constructed. Dr. Ingrid Nordahl, who became Norway's chief tunnel engineer in 2020, described the achievement as creating a parallel underground country that functions regardless of surface conditions. The tunnel network had evolved into a sophisticated transportation system with its own traffic management, emergency services, and maintenance infrastructure. Perhaps most astonishingly, the tunnel network had become completely integrated with Norwegian daily life. Over 80% of Norwegians regularly use tunnel highways, and many communities were more accessible through underground routes than surface roads. The tunnels handled over 300 million vehicle trips annually, making them essential infrastructure for the Norwegian economy and society. The technological sophistication had reached levels that seemed futuristic. Advanced tunnel systems incorporated automated traffic management, real-time air quality monitoring, and emergency response capabilities that could handle any conceivable safety situation. Some tunnels featured underground rest areas, emergency medical facilities, and communication systems that maintained connectivity in the most remote locations. Economic transformation had exceeded all projections. The tunnel network generated an estimated $200 billion in economic activity through improved connectivity, tourism, and business development. Remote communities that had been economically marginal became attractive locations for businesses and residents. Property values in previously isolated areas had increased by 300–500% in some locations. International expansion of Norwegian tunnel expertise had created a global industry worth over $20 billion annually. Norwegian companies were building major tunnel projects on every continent, from underwater highways in South Korea to mountain tunnels in the Andes. The expertise developed in Norwegian conditions was adaptable to underground construction challenges worldwide. Climate resilience had become a crucial advantage as extreme weather events increased in frequency and severity. During the severe winter storms of 2023–2024, surface transportation was disrupted for weeks in many European countries, but Norway's tunnel network continued operating normally. Underground infrastructure had proven to be climate-proof in ways that surface transportation could never achieve. The environmental benefits had surpassed initial expectations. Wildlife studies showed that animals adapted well to tunnel infrastructure, with many species actually benefiting from reduced surface traffic. Mountain ecosystems were healthier because tunnel construction eliminated the need for extensive road networks that fragmented habitats. Carbon emissions from transportation decreased as tunnel routes were more direct and efficient than surface alternatives. Urban planning had been revolutionized by tunnel technology. Norwegian cities began incorporating underground transportation into comprehensive development plans. Some communities developed entirely underground commercial and residential areas connected to the tunnel network. The concept of tunnel cities emerged as a new form of climate-adapted urban development. Space technology applications developed as engineers recognized that tunnel construction techniques could apply to building habitable structures in extreme environments. The life support systems, emergency protocols, and isolation management developed for deep tunnels were being adapted for potential space exploration and colonization projects. Research and development continued to push tunnel technology boundaries. Experimental projects tested magnetic levitation systems for underground transportation. Automated tunnel construction systems reduced the need for human workers in dangerous conditions. Advanced materials. Science developed tunnel linings that could last for centuries with minimal maintenance. Educational impacts reached global scales through partnerships with universities worldwide. Norwegian tunnel engineering programs attracted students from every continent. The accumulated knowledge from 30 years of tunnel construction was being codified into new engineering disciplines and international standards. By 2024, the cost-benefit analysis showed returns exceeding 400%. The total investment of $50 billion had generated over $300 billion in economic value, while providing incalculable social and environmental benefits. The tunnel network had become one of the most successful infrastructure investments in modern history. Cultural transformation had created new forms of Norwegian identity that incorporated underground connectivity as a normal part of life. Children growing up with tunnel access had different relationships with geography and weather than previous generations. The concept of seasonal isolation had largely disappeared from Norwegian experience. International policy frameworks were being developed to facilitate tunnel construction across national boundaries. Proposed projects included underwater tunnels connecting Norway to Denmark and the United Kingdom. The tunnel network was becoming a foundation for European integration and connectivity that transcended traditional geographic barriers. The success had inspired similar projects worldwide, as countries recognized the potential for underground infrastructure to solve transportation challenges. China launched massive tunnel construction programs based on Norwegian techniques. European Union funding supported tunnel projects that would create continent-wide underground connectivity. The lesson of Norway's tunnel revolution extends far beyond transportation engineering. It demonstrates that geographic constraints that seem permanent can be overcome through sustained investment in advanced technology and engineering. Norway proved that no terrain is too challenging when human determination meets sophisticated engineering capabilities. As thousands of vehicles travel daily through Norway's underground highway network, they represent more than just efficient transportation. They symbolize humanity's ability to adapt environments to human needs while preserving surface landscapes for ecological and aesthetic purposes. The sight of modern highways carved through billion-year-old granite represents the convergence of human ambition and geological time. Norway's conquest of its mountains through tunnel engineering shows that infrastructure development can enhance rather than degrade natural environments when properly planned and executed. The underground highway network proves that the future of transportation may lie not in dominating surface landscapes, but in working with geological structures to create transportation systems that function regardless of climate or weather conditions. The 1,000 kilometers of tunnels beneath Norwegian mountains stand as monuments to human engineering ingenuity and long-term vision. They prove that the most challenging infrastructure problems can be solved when societies commit to innovative solutions and sustained investment. In a world facing climate change and extreme weather, Norway's tunnels offer a blueprint for creating transportation systems that are truly climate-proof and sustainable for centuries to come.